science for social good as the last one. And my name is Raed, I'm working in DSAP. And so the first speaker is Mackie, and he's going to talk about using public and private data to improve employment outcome, which is also the project I'm working on right now with Tristan. So let's go.
All right, great. All right, so do I need to, can everyone hear me? Do I need to talk into the talkie thing? Yeah, all right. All right, so I'm going to try to get through this fast so we have time for Q&A and more of a discussion, because I think that's a lot more interesting. So as Eddie said, this is work that Eddie and Tristan and G and Stan and Matt's not in the audience, but Christina as well, a bunch of folks on the team are working on, all right, are working on. And we're mostly going to talk about some of the things we've learned in doing this thing called the Workforce Data Initiative. And it's mostly about the messy human part of doing data science for social good, and what are some of the things that we reluctantly need to acknowledge as data scientists as necessary skills we need to develop if we want anything that we do to have impact in the real world. We're all from the Center for Data Science Public Policy. It's always good to start. I think Jack Candy said always start a presentation with the apocalypse to get everyone's attention. So we're going to talk about the robot apocalypse. Some of us in this room are kind of working towards it as quickly as possible. Maybe some of the travelers from the future in the room are here to prevent it. I don't know. But it is probably something that most of us are worried about, that robots are all going to take our jobs. And so it turns out that we have some policy mechanisms in place and some institutional mechanisms in place in the United States to try to stem the tide of the robots taking our jobs. And that's our education and workforce training system. So it's the thing that what's marveled throughout the entire United States is the ability for us humans to acquire new skills. So let's talk a little about how it works, right? If I'm a military spouse and I move around a lot and I move into new labor markets quite a bit, and as a result, right, in moving to a new labor market, might find myself and the prior skills that I have not really having a job opportunity in new places that I've moved to. And so I look around and say, well, it looks like there's a training program that's sponsored by the state where I can get my registered nurse's assistant license. I go to that, and then through that I can get gainful employment and start to get my checks through Workday, which is great. And an economist 3 or 4 years later will look at the data that is me and all the other people that went through this particular program and say, did that work or not? Like, did people that went to this program actually end up getting jobs? And how much did they get paid? Right? So this is currently how we go about doing this. And unfortunately, because of the very slow cycle of analysis on this, these programs have a tough time knowing whether they're training people on things that actually matter for employers in their area. And sometimes you end up with, for example, a training program here in Chicago for 5 years was training people in their mortuary science. Right? People are dying all the time. Seems like a stable business, right? So they would train people every year, about 50 people to this program. And it wasn't until someone looked at the data, they found out, oh, that program has a 2% placement rate, which means that if you went through this program for a year, your chances of getting a job within 9 months of having left were about 2%. And that's because if you knew something about that market, turns out mortuaries are all family-owned businesses and they tend to hire within their families. We don't want that to happen, right? That's, you know, we're all going to need to be retrained a lot faster, and we don't want to be spending our time and money or public time and money on things that are unsuccessful because they don't actually line up with market needs. And this is a general problem. Right? The pace of change in the labor market has outstripped the pace of change for public data on skills, trainings, and jobs. This is something that World Economic Forum also brought up. We have to become more specific and much faster at understanding the changes underway if we're going to keep up and if all of us are going to have jobs. So a few years ago we kicked off something called the Workforce Data Initiative, where we felt like we as publicly minded data scientists could make a few marginal but hopefully helpful contributions to improving that, our ability to be much more specific and much faster in understanding. And that is, one, we need much better open data on skills, competencies, and credentials in jobs out there. There are a lot of companies that have their own internal, what are called taxonomies about what the market needs, but none of that information, very little of that information is available for most of us in this room to be able to use and build tools on. Second, we need to have, instead of these long 5-10-year cycles of knowing which programs are working and not and actually getting people jobs, let's speed that up. Let's make it so that the data on the outcomes, the wage and employment outcomes of every education training program in America are publicly available every year. And then do it in a way that actually allows everyone in this room to use that data to build really cool algorithms and productive tools that help people match the programs and jobs. Okay, not too ambitious. So that was our goal we set out a few years ago to do. What have we learned about how to do this and why it's hard? And these, I think, are lessons certainly that we've learned, and hopefully lessons that will be beneficial to you. So one is that, and you know, we're in Chicago, so of course it's going to be a talk about incentives. Since incentives matter, it pays for all of us to become policy wise. And this is why. If you, back in 2014, decided to read the Federal Register, right, the set of laws that get passed, you would find a law in there that was something called the Workforce Innovation and Opportunity Act. It's this governing legislation that was supposed to help us get ahead of the robo problem. Oh, sorry. And in there, in section 116, buried deep, there's this little parenthetical statement that ends up being really, really helpful. The state, and this is for all 50 states, shall make available, including by electronic means. This is actually parenthetical that was slipped in a little late in the game, thankfully. This is where technology lobbyists can be really helpful, right? Because otherwise PDFs would have complied with the law. An easily understandable format, the performance reports for the training programs, right? What that means is that thou shalt make your data about whether people are getting jobs from that mortuary science program publicly available for people to build cool things on. Now, if you went and asked the states whether they could do that, which we did, most of them said, nah, no, we can't. It turns out this is a really hard problem to solve. So we said, okay, great. We're actually going to go about building a toolkit that will help all of you states make this data possible and public. So we wanted to build a toolkit that made it a lot cheaper, etc. And this is what needed to happen, right? This is the world we wanted to create, right? We had data in training providers. These are 200,000 of them across the country. These are everything from coding boot camps all the way up to four-year colleges. Wage and employment data. This is locked away in state databases that is essentially your tax records, right? Every state has this. And then who goes through these different training programs? This is locked away in a few hundred different workforce agencies. Right? We had to get all that data to talk to each other securely and safely, combined, be able to clean it, analyze it, you guys get this, aggregate it in a way that's privacy preserving, and eventually expose it in a way that certainly can go up to fill that particular law, but more importantly can be used by other people to do really cool things. So we knew that we couldn't just do a nice little project and say, here's the tools, go use them, because no, adoption would be the major problem. So we created a technical working group. We were the technical lead, but we got some policy leads that had large networks across the entire country. We got a few pilot states to say, yes, we're willing to do this. We had a technical working group that ran for over a year and a half, trying to define the nature of the technical problem so that we make sure we were building the right thing, and made sure that as we were building, we could get feedback from that large group of states and providers so that we could fix the things that were broken, right? And to do it in a way that would map to most of their existing source systems so they didn't have to rip out the guts. We just had good ETL. 5 minutes? Okay, great. And ultimately use an entirely open source stack so that the existing vendors could integrate with it, or folks, states, if they wanted to, like the state of Texas, just deploy it themselves. The last thing we did, we said, well, when we're doing this, we want to make sure that we're driving value in the release of the data. Otherwise, if it's just for compliance, it's not going to really drive much market change. So we brought in folks like LinkedIn, Burning Glass, as well as some nonprofits like the San Diego Work for Partnership and Coach America, and some great research partners to be able to come in and support the work that we're doing in a number of different ways. We can do that in the Q&A. But most importantly, one of the really cool things that's happening in Colorado as a result of, for example, is LinkedIn is actually going to be ingesting the outcomes data into a new application that they have called Training Finder, so that everyone on the LinkedIn network will be able to have recommended to them new training and education programs that are available in their area based on whether those training programs are actually working. So getting all the way to application. So great, we've got states that are starting to deploy it. We've released the toolkit. Blah, 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 great. The important thing here is that there are a lot of these types of untapped, there are a lot of hidden parentheticals in a lot of the policies that are written that are opportunities for all of us to do this kind of work that is market changing, that can have a real social impact. So it pays for us to get to know some of those parentheticals and see the opportunities to the rest. Okay, second, sense intensive matter, it pays to get to know things that businesses care about. And this is the second kind of major problem we need to figure out is we wanted to make it possible so that when you put a resume up into any number of these kind of resume posting sites, you can be automatically recommended to jobs that are a better fit for you based on things like skills and competencies that are embedded in both the resumes and the job postings. The challenge there is that, and then eventually be guided along a nice little learning path. And the problem is, what's missing in a lot of this is a common language for skills, at the lowest level kind of atomic unit of competencies. And we didn't have, and we still don't have, a really good, low-level, rich language of skills in America. We have something called ONET. That's a good place to start. It's a nice trunk of a tree, but it's missing a lot of branches and leaves. It doesn't have Java in it, for example. We knew if we were going to build an open taxonomy of skills that could be used in these types of applications, we were going to need a broad set of coalition partners. And a lot of them were private sector actors, right? Because there's a whole bunch of data that's in their systems that no one else has access to. But if we were going to do that, right, we were going to have to figure out what they cared about and why they would actually be willing to pool their data with some of their competitors to build something that was publicly accessible and not proprietary. We spent a large part of the last year and a half just trying to figure out those private market incentives and structuring data sharing agreements that would allow for those folks to be willing to pull the data in. And the team has gotten to work doing some cool machine learning stuff. We actually have now exposed an Open Skills API, a number of new publicly available data sets on skills, jobs, etc. that you can find the data at work.org. And we've got a broad set of partners who are starting to use that data for value-added use in the marketplace. And then lastly, since this matters, we all have to get better at advocating for smarter procurement at the state and local level if any of the work that we do is going to matter. And I want to tell one quick narrative about this that this is a sad one, right, that we want to avoid in the future. And that is, one of our partners in a lot of this work has been a great organization called Coach America. They, using some of our APIs, built an application that reduced the intake time for someone who wanted to go do a training program from 5 hours to 15 minutes. That was the time between when they walked in the door and when someone said, yes, you qualify and I can help you, right? But it relied on an API that the state of California had told its vendor, a vendor that has about 60% of the market for these state systems, to expose, right? This vendor had to expose an API. The vendor, after a lot of cajoling, convinced the state to shut down that API because they wanted to own the walled garden. And so something that was actually helping people go from taking 5 hours of their time to just 15 minutes of their time to get the help they needed is no longer possible because of a stupid procurement rule. That's something that we can all change, right? We need to think of kind of an Ivan Illich approach to tools for conviviality around the technology we build. should induce cooperation. These should be transparent, decentralized, flexible, and redundant. And when we do that, when we espouse those principles in what we build and lobby for them in the technology policy that we all should be advocating for, we end up with a better ecosystem that our solutions can work. So thank you all very much, and I look forward to the next one.
You can find Matt. You probably won't find Matt today, but yeah, graduate on the fine. Okay, so next speakers, I'm going to introduce Raed Mansour. He's going to talk about reducing the leaks in the mound through in Chicago, from the Chicago Department of Public Health.
Thanks.
Where are my slides?
Yeah, I know.
I don't have any.
Oh, really?
Yeah, nothing. Raed asked me this week, so I didn't prepare anything. Good? All right. My name is Raed Mansour. It's almost pronounced like Raed's name, same but different. He's the only other person I know that has the similar name. I'm the director for the Office of Innovation at the Chicago Department of Public Health. And has anyone heard of me? Two? Good. That's point one that I'm going to bring up about partnerships and collaborations. Yeah, that's a good one. Keep that one up. So we have about 20 projects, 5 data science projects, several apps, simulations, data visualizations. And the lead model is just one of a small part. And creating collaborations and partnerships with data scientists isn't very easy. Who here works in government? Civil servant? 5. I wish it was half the crowd. And I assume the rest of you are data scientists? No? I'm not one. I know enough to be dangerous, though, I think. Let me tell the story about how we got to this specific data science project. In 2013, I heard about data science for social good. And I scanned the environment at the Department of Public Health, and I pitched five projects to Raed. It was December. It was cold. He came alone without a jacket. Anyone knows that Raed doesn't wear a jacket in winter. So we pitched these, and he picked lead. I didn't show him any data. I just told him the story. This is well before Flint, Michigan, so it wasn't on anyone's radar. We have data. We have a lot of data. Part of our mission is, and I don't like this word, but it's a public health term, to undergo surveillance so that we can detect signals within all the noise, so we can approach and mitigate and abate the diseases that creep up, and lead poisoning is one of them. So we have 20 years of blood lead level data, home inspection data, and we know that lead was banned before, after 1978, so Cook County had that data. We have census data. There's Illinois Department of Public Health birth certificate data, Illinois Department of Human Services WIC data, so we can go on and on. But these weren't all brought together, and I think Raed saw that. So after 6 months of creating a contract, in 3 months, they built the proof of concept in R. And then he created his center right then and there. And in 3 months, they flipped it to Python. And in 2 years, we implemented it. We didn't operationalize it yet. In 1 or 2 weeks, I don't know if Tom is here. Tom Schenke, our Chief Data Officer, who's leading that end of the project. In between that time where Raed said yes and where we are now is 6 organizations, 5 grants, about 50 people. And when we talk about collaborations, the first point what I brought up when I said, do you know me, is number 1, there are no lone wolves in these projects. One individual, one data scientist, one government, one whoever is not going to make or break this project. You're not going to even get started. It took a chief medical officer, deputy commissioner, a commissioner, a medical director, a program director, the Office of Informatics, Office of Innovation, the Office of Epidemiology, the Department of Innovation and Technology, Alliance of Chicago, who provides electronic health records, where we're porting this risk score, and I'll tell you the end game of this product. The Public Health Institute of Metropolitan Chicago, CPS, who am I missing? University of Chicago, of course, Center for Data Science and Public Policy. That last part, the policy part, is the toughest part. And so individuals aren't going to get famous getting into this project. So if you want a resume builder, it's easier to go to Google than the city of Chicago, probably. Number two, the important point, if you see all those partners and people involved in this, is know yourself and know your partners. I know some people were talking about learn the business process, it's very important, but know your limitations. You're not a HIPAA attorney. You didn't work in the field on the west side and the south side for 15 years, like some of these folks did in public health. So appreciate everyone else's content expertise. Don't go in guns a-blazing, I'm gonna solve the world's problem, you guys are government are so backwards. Right? Know your limitations, because you will get frustrated when you don't get what you want, and you have to be persistent but patient, while all the attorneys work out all the details, right? And number three, part of this working together is trust and respect and understanding the endpoint. So what does this model do? It calculates the risk score of a child getting lead poisoned before they're poisoned. Right now, we have to wait till the child is poisoned, and we get a blood lead test from the state, and then that initiates an inspection response. By that time, that kid is done. You're poisoned for life. So it's very reactive. But what if we can get to them before they're poisoned? And that's what this model does. It's really been a great partnership and a great model. But how do you operationalize it? Do you give math to an inspector? Here you go. That's what happened with one grant. We had a CAGO competition, and they said, all right, let's get going. I was like, wow, I can't use this. Government's like gears on the old clocks, 20 gears, small ones, large ones, some going fast, some going slow, and you have to insert this thing without stopping it. Otherwise, no inspections. You're going to disrupt the whole process. So there is a lot of understanding going on and a lot of technology, and that's why we depend on Tom's expertise in implementing this and now operationalizing it. So how do we operationalize it? Well, we had an idea. Why don't we send it upstream? Why don't we give it to doctors in electronic health records, so that when a woman is pregnant, the doctor can see the risk score in the chart and state, we're going to get an inspection before that child's born, make sure there's no lead in the home. And if she brings her child in, let's get a blood lead test right now and order a visual inspection. They're not poisoned yet. Let's prevent that from happening so we can mitigate the problem. So that is primary prevention. That's pushing it all the way out and not being reactive, but being proactive. We validated the model. We have 4 federally qualified health centers, community clinics, basically. And the API, if you go into GitHub, the City of Chicago's account, you can see Chicago Lead Model. It's actually called Lead Safe, and you can go to Chicago Lead Safe API, and you can see the details. After the pilot, with the support with the Robert Wood Johnson Foundation, we're going to open it up to the rest of the hospitals in the city. We can push that prevention across different health centers. And that's where the trust comes in, and that's where we rely on each other's skills to get that job done. So yeah, it took a while, 3 years, but I think it was all well worth it. And those components, those 3 things, don't be a lone wolf, know your limits, and respect the content experts, and build trust. And it was a tough road. There's something Kennedy said in 1962, we don't go to the moon because it's easy, we're going because it's hard. And you don't want to avoid the hard stuff. Sometimes a lot of this is not easy. And that speech was to motivate people in the innovative spirit of discovery and accomplishing the hard stuff. So as data scientists, it's not going to come hard, it's not going to come easy, but don't be afraid to partner with government. And that's it. I don't know if I have time for questions.
You actually have time.
All right. Anyone have any questions regarding this, or you guys had enough of us? No? I don't have any. My glasses are not. Yes?
Did you explore other intervention options besides the doctors? Did you have any
Yes.
other ones?
Oh, yeah.
So how did you kind of sort through the options there?
Well, we are giving the inspectors an application that they're going to do while they're out in the field. You know, you have to knock on the doors, and if they don't answer, you go to the next house. Which house do you go to? There's a lot of houses and a lot of homes with lead paint. Most of Chicago, I think 80% was built before 1950. And so there's a lot of rehabbing going on, but not in certain neighborhoods. And that's one option. The other option is we used Ideas 42. Anyone ever hear of them? Behavioral science group. Obama used them in the White House, and he put out a proclamation that there should be more use of behavioral science. Behavioral economics. Richard Thaler out of University of Chicago. You guys know Nudge, book Nudge. It's not mind tricks, but they helped us write a non-governmental letter that we use this predictive model to mail to the top 4,000 people that were at risk so that they can request an inspection. Another use, we used Imagine Inglewood If and Metropolitan Tenants Organization to do visual inspections on the riskiest homes. And now we're going to use community health workers out of Sinai. So there's a lot of ways to use this model, just ideas and people actually approaching us now. Hey, we heard you have the model, let's try it this way. So that spurred more innovation. So you have a simple innovation here that has far-reaching impact into the healthcare system, health transformation, and it's going into agencies, nonprofits, and different avenues to solve this problem. Any other questions? One? Last one? I can't see. Stand up or no more? All right. Thank you.
Next, welcome Kid Rodolfa. Yeah, so he's also one of the scientists in DSSG, and he's going to talk about data-driven inspection for secret housing in San Francisco.
Yes, I'm with the Center for Data Science and Public Policy as well, and going to be talking a bit about a project that we have with the City of San Jose, California, trying to look at housing inspections, particularly focused on health and safety. So just kind of as a motivating example, a couple of years ago in Berkeley, California, a balcony collapsed and killed several people and injured several others. And this is kind of just a sense of why this is so important, that if we can inspect these housing units and look at them ahead of time and figure out what's wrong with them, we can fix structural defects, fix fire safety hazards, fix electrical hazards that might cause fires, and make sure that people, everyone across the income spectrum, no matter where they live in the city, has safe housing that they can rely on. And so in the city of San Jose, this is the responsibility of the code enforcement team. So this is a group of folks who work out of City Hall and go out and inspect properties. Part of their job is to conduct building inspections when new properties are being built. But in particular, our work here focused on a program that they have with multiple housing units. And so that's any housing or any property that has 3 or more units. A lot of this is apartment buildings, but it's also like hotels, even fraternities and sororities, assisted living facilities, so across a wide spectrum. But of course their fundamental problem is there are only so many of them, and there are something like 4,000 properties in San Jose. Many of them have, anywhere from 3 to hundreds of units. So they just can't inspect everywhere all the time. And so they, more and more as time's gone on, have been thinking about how do they prioritize, how do they use their resources efficiently to make sure that they're focusing on the places that are most at risk for health and safety violations. And so that's kind of where our project comes in. I want to talk a bit about the collaboration and sort of the steps of how we work with them as a partner. Many of the, or I should say all of the Center for Data Science and Public Policy projects are really very tight collaborations with the project partners. And so these aren't things like, oh, just give us the data and we'll go away for 3 months or 6 months and then we'll come back with a magic model that will solve all your problems. It's much more of a back and forth, working very closely with them, ingesting the data, understanding the problem on the ground, how people think about this currently, and then going and iterating on the modeling process with them to figure out what is going to best kind of help them and best fit into their current practices. So we'll start with the kickoff and get the data from them, usually in some sort of extract that we can ingest into our systems. Although at different projects, sometimes this will be actually an agreement that allows us to access the data within their systems, but often we bring it into our own. And then we go through a phase of exploration and summary statistics and just kind of like trying to get them something out of the data pretty immediately. One, so they can kind of help see some insight pretty immediately, where some of the modeling process might take a bit longer, but also so we can get their feedback on what we're looking at, where things pop out that might be sort of surprising to us, where they can explain it away very quickly. Oh yeah, well that's when the system changed over, or that's when this policy change was. So you shouldn't focus on that as something that is like happening on the ground. And then that will help us think about what's our modeling approach, what are the features that are going to go into the model, and how do we think about the modeling problem. Everything from what exactly is a label for this problem, what's a 1, what's a 0, in the sense of do we care about certain classes of violations. Their inspections can look at anything from overgrown lawns and weeds and stuff like that, and blight, to things like structural defects where a balcony might collapse. So how do we narrow our focus there? Are they constrained to only be able to look at a certain number of buildings, and how does that inform the modeling decisions and how we're going to evaluate the models? And then we'll run initial set of models and kind of have an iterative process even there, where we'll run our modeling, give them kind of, here's an initial list of where we think you should prioritize. Does this even make sense to you? Are there surprises? And what does that tell us about our process? And kind of go through a feedback process there before kind of getting to a final model where we'll go out, bring it to them, and really discuss it with them in detail. And kind of where we currently are, and this is an ongoing project, is in a field trial phase, where now they have lists of properties we think they should inspect. They have kind of their current practice, and we're testing those head to head. And then kind of from there, we'll move on to sort of more of a deployment. So just to talk very quickly about some of the models and kind of what we've seen. If you went at all to some of the model selection and bias sessions yesterday, you probably heard a little bit about how we think about some of these modeling problems, where there's kind of this time series component, and we want to think about validation in time. And so rather than doing sort of typical cross-validation that you'd see in a lot of kind of like data science 101, we think about cross-validation in time, where we split the data set up through time and making sure that we're always predicting, training the models on the past, predicting to the future, and validating from the future as we do our model selection and understand model performance. And so then we, of course, build thousands of different models with different modeling types, different sets of hyperparameters, and do a big grid search across these using the temporal cross-validation to make a selection. In San Jose, we focused on precision at the top 300, so we want to think about how the model is actually going to be applied. They only have the ability to inspect about 300 properties in a 3-month window, so we look at the top 300 and make sure we're catching as many high-risk properties as we can. And so then just kind of a quick look at model performance. Recently, San Jose's been moving towards a very manual tier system, where they've divided properties into 3 tiers by hand and kind of using on-the-ground knowledge. And so we have sort of 2 counterfactual sets, essentially, to compare against. Before that system was put into place, and after it, they saw a jump of about 13 percentage points in the number of properties that they inspected that had a serious violation and a health and safety risk. And then our kind of out-of-sample validations indicated that that the model would help them focus even further, bringing that rate up to 77%. So the idea here being that they're already thinking very much in this direction, and they're already trying to move their program in this direction, but right now doing it in a very manual, very tedious way, and we can kind of layer modeling on top of that and help them refine those processes and make them faster and a little bit more automated as well. And this is just kind of a quick view of, where are these properties in the city, and how does what the model would suggest sort of overlap with what they would kind of do currently. And geographically, there is a lot of overlap, but we're kind of picking out a little bit riskier buildings that are maybe just down the street from the one that they might have intended to inspect. And I'll just kind of run through this very quick, but the things that kind of come out as important are often pretty intuitive. So how long has it been since the last inspection? Because that, when an inspection happens, problems get corrected, and then over time, new problems arise. I think one that's kind of useful to highlight is the absence of recent building permits, which isn't something that we thought about in our initial modeling, and was kind of came out of this feedback loop of us building things and kind of going to them and them mentioning, well, one thing that we see a lot, or one thing that kind of stands out, is properties that haven't pulled building permits recently, because it means one of 2 things. Either they're not doing the maintenance work they need to be doing, or they are doing maintenance work and they aren't getting permits for it, and so there's a problem there. It might be shoddy work. So kind of this back and forth collaboration helps us identify new features to build and new things to bring into models, and that ended up being a very important feature. And then, of course, as you might expect, the history of inspections and violations at the property, and also the history of inspections and violations at nearby properties, where you can get a bit more data. And so just to kind of acknowledge who we are, and the partners at the City of San Jose played a huge role in this, and also our funding from the Laura and John Arnold Foundation through the Civic Analytics Network. and also to mention that this project was actually kind of initiated with Johns Hopkins University, and they kind of came to us through them. So thank you very much. I know folks want to get to lunch, but you have, I guess, a minute or two for a question or two if anyone wants.
Can you talk a bit about the deployments after you had the model? I saw some apps up there. Did you build an app that was project you were using?
Yeah, the maps up there are actually just for Tableau. So we're kind of like right now at the field trial phase, and then the sort of handoff deployment for this particular project will kind of come later. I think it varies a lot from kind of project to project. Here they have a number of folks who are kind of on the IT side, and there's a strong chief data officer there in San Jose. So we'll be able to work, I think, really closely with them to help build something. Whether that ends up being, an app with a nice front end, or something that, somebody kind of more technical can run and generate a list. Because the thing to care most about is actually just the physical list of here's which properties each person should go inspect in the next 3 months, and then refreshing that. So it might be a little bit more kind of back-endy in this project. Other projects are for sure, like the piece work that DSAC does, has much more of a front end that I was talking about at the plenary session earlier.
Just out of curiosity, how long is the relevance or the lifespan of one of these projects for relevance? So obviously, parcels are going to change, environment's going to change, that kind of thing. So I don't know if this is too infant to know that, but what's your experience and how long this is relevant?
Yeah, I mean, I think our hope is to kind of keep it relevant with time, and that it's, what you hand off is something that can be retrained and continually learn, as policies change or as parcels change. So it's not that there's this fixed set of information and you build the one model and it's just the one list, but that it's kind of a process and something that can live. So hopefully, as long as the program exists, right, that they'll be able to use this to make themselves more efficient. I think that, but I think it also, like, in kind of the more microcosm, I guess, of that, right, like that I think it probably varies a little bit context to context in terms of how fast policy and things are changing on the ground. So it's probably hard to give like a really broad answer, and certainly for this, right, it's a couple months in, yeah. Cool, anything else? Otherwise we should.
So yeah, feel free to grab a lunch and talk to the big crowd here, or people buy the posters, and enjoy the lunch. And thank you for your participation.